Hi, and welcome to an introduction to embedded control systems. An embedded control system is a small computer, or a microcontroller, that goes inside of another device, like a thermostat for example, to help it control something. So you know what a thermostat does. It turns the furnace on or off depending on the temperature that it measures and the temperature that you set. An old-fashioned dial thermostat is a simple control system, but it doesn't have a computer inside. A modern digital thermostat has a microcontroller inside of it, which makes it a lot more versatile. We're going to look at a simple digital thermostat and see how a microcontroller is used. Now, a real digital thermostat has a lot of features, and we could spend a year covering them all. But we can explore a very simple version of a digital thermostat and see a lot of common microcontroller features in use. So this one is just going to control a furnace. It'll be pretty simple. So first, what do we need to understand about this system? Well, we know that a thermostat controls a furnace. If the temperature is too cold, that means below the point where we set it for. If the temperature is too cold, the furnace should turn on, and if the temperature is warm enough, the furnace turns off. So it's just fully on or fully off, okay? Contrary to what some people believe, you don't really control how much a furnace comes on. It's either on full blast or it's off, okay? So if you get home to a cold house and you turn the thermostat way up to 85, hoping that it'll get to 72 that much faster, it won't. Okay, back to the point. The thermostat checks the temperature, compares it to a preset temperature, and decides whether to turn the furnace on or off. And it just continually repeats that procedure. So what the thermostat system does, it controls a furnace. If it's too cold, the furnace turns on. If it's warm enough, the furnace turns off. Pretty simple, right? Now, every computer program, no matter how complex or how simple it is, every single computer program does three main tasks: input, process, and output. So a computer game reads the movement of the joystick or the controller buttons, and that's its input. It makes decisions based on that input information. That's the processing part. And it displays different scenes on the screen based on the input and the processing. So there's your output. Okay, a digital thermostat is very similar in that it takes a preset temperature from the user. That's its input. It checks the actual temperature, so it measures something. That's more input, stuff coming into the computer. It compares the actual temperature to a preset temperature and then makes a decision about what to do with the furnace. That's the processing part. And then last, it turns the furnace on or off. That's the output part. And if you take a look at this, you'll see that once it finishes the output, it goes right back up and does the whole process over again. Okay? When you think of a lot of other computer programs, Microsoft Word or something like that, that program actually ends when you click the X to close Microsoft Word. The program comes to an end. In embedded control, our programs never come to an end, not unless you turn off the power, really. Okay, so a thermostat, you can't just say, well, it's too cold, turn the furnace on, and then the program ends. What's going to happen? Your furnace is going to stay on forever. So these programs run in what we call an infinite loop. It just repeats over and over again. So every microcontroller is going to be repeating the same three steps: input, process, output, over and over again. So let's get into a little more detail here. Okay, when we look at the input, I want to make a distinction between input devices, that's hardware, something you can physically get your hands on, and input data. Okay, that's a piece of information. So if we were just measuring temperature with a plain old thermometer, the thermometer is your hardware. That's your input device, or your device. And then the information that you read from that, it's 72 degrees. That's your input data. Okay, so in this case, in this system, the temperature sensor is an input device. Okay, temperature sensor is a little piece of electronics. There are various kinds of temperature sensors, but we'll talk about some of those later in the course. Okay, so the temperature sensor is the input device, and it's going to read a piece of information in, and it's going to come in, and we're going to store it in a place called actual temperature. That's our input data. So this is the input device, this is the input data. Okay, so it needs to know what the actual temperature is in order to know whether to turn on the furnace. It also needs to know, well, what temperature do we want it to be? That's our desired temperature. So that's another piece of input data, and that comes from a device called a keypad and a person. Okay, and if I were drawing this on the whiteboard, I couldn't do a better job than that. My wife is the artist in the family. Okay, so once it gets its input, it reads the actual temperature, it knows what temperature we want it to be. Now it has to do some processing. Okay, so it's going to compare actual temperature with desired temperature and actually ask the question, is it too cold? Really what it's doing is asking, is actual temperature less than desired temperature? Okay, but we can say in plain English, is it too cold? Okay, and then it makes a decision on what to do, and then it does it, and that's the output stage. It turns the furnace on or off. Okay, now the output of our microcontroller is going to control a furnace control relay. Okay, a relay is an electromechanical device, or it can be a fully electronic device if it's a solid state relay. But it's a device that can, it allows a low voltage system like a microcontroller to control a high voltage system like a furnace. So it's just a little in between here. So the output is going to control the relay, and the relay is going to turn the furnace on or off. So that's our introduction to embedded control systems. In the next video, we're going to see how output ports and relays work.